So right now, I have the devices here in front of me, and I just want to show you the functionality and the different things at play in the product. So over here we have the chest distance sensor. This one is vital for sit and down mode, so it makes the device able to detect whether the dog is sitting at a reasonable angle with a reasonable chest sensor distance or laying down. Laying down is pretty simple to understand. When the dog is laying down, this distance should be roughly 0. So whenever this is giving anything that isn't roughly 0, the dog is corrected. In here is where we have gyroscopes and a radio to communicate with this device. And that means this device can communicate up to a mile away with this one. The belt clip is always going to be closer to the remote, and so it just communicates through Bluetooth Low Energy, and it communicates the angle of the handler so that when these angles, the angles between the handler and the harness are mismatched, this device will give a loud noise, will produce a loud noise. And so we can show that here while in heel. This is just some data on the position of different things. So like the chest sensor distance is currently reading the distance from the tabletop to the roof, which is about 1700 millimeters. And while it's in heel mode, I can show you just how these different gyroscopes, when it's beyond around 90 degrees, when the difference exceeds 90 degrees, the dog receives a correction. So as you can see, it's in heel, and as I start turning the device, once it goes around past 90, it will correct the dog. And you can see this for the other side as well. It corrects the dog. Now these use very good gyroscopes. They are calibrated by using a figure 8 motion. So to calibrate these, in order for each device to face to agree on roughly the same direction, they, like in this position, they should be roughly equal. They simply need that figure 8 motion, and they will be aligned. This is due to the magnetometer that's built into each of these devices. So that's what allows the quick calibration. And so that was heel. Next, I'm going to show you that this is a little gamepad programmed so that each of these buttons is a mode. This is simply a manual correction, so that will create a noise, and this is the easiest by far to press. It's a thumbstick, and in any direction, it will produce free. So if at any point a dog is in heel or in any position, it will be almost immediate for someone to say, oh, I made a mistake, and quickly put their dog into free. This is so that the dog doesn't receive any unfair corrections when someone has made a mistake. So now we have different modes like come mode. As you can see, because this is not extended, it understands that the dog is very close, and so we'll continue to put the dog in free. As you can see, if we put this into a sit position, the device, even though it's roughly 180 degrees, the chest sensor distance is reading a very large number. And this shows that it's unreasonable for the dog to be currently in a sit, but let's say the dog was at roughly 180 degrees and this sensor was reading roughly 0. So we can put the dog in down, and if we cover up this, then it will stop giving a correction. As soon as we let go, it creates that correction again, but if we cover it up, it no longer makes that sound. So this shows that it's accurately detecting when the dog is in and out of position. Now, the other mode is sit mode. Sit mode operates similarly, but it uses a function that is calibrated for each dog to allow a certain amount of chest sensor distance per given amount of angle. If right now it's calculated using a linear function, there is a linear relationship between the amount of chest sensor distance allowed for a given back angle. And so you can think of if on an X and Y plane, on the Y axis, the dependent variable would be chest sensor distance and the independent variable would be back angle. So if at any point the red chest sensor distance exceeds the maximum allowable chest sensor distance determined by this function, it will create that alarm and will show that, okay, well, obviously the dog is out of position. The last mode is simply manual correction. And all this does is manually correct the dog if they've done anything else. In the future, when we actually have e-collars implemented, this would actually create some kind of shock, vibration, or ultrasonic sound to function as the correction for the dog. The only mode I think we haven't shown is come. That will take a second to set up. I can cut this out. Oh, wait, pause. So now that my partner over here is holding it out really far, I'm going to put it into come mode. As you can see, as soon as I put it into come mode and it's not detecting a decrease in the distance between the handler and the dog, it will start sounding an alarm. But as soon as he starts decreasing the distance, it will detect that and the alarm will no longer sound. But let's say he starts moving the other direction. Oh, I put him in free. We're gonna cut that. It's fine. Let's just restart. No, yeah, because I can just pause it. So I'll just pause it. Continue. So now that I have my partner here, I'm going to put it in come mode. And as you can see, if the distance is not decreasing between the handler and the dog, then a noise will sound. But as soon as he starts coming closer to me and letting the leash retract, then it no longer plays that sound. And now that he's close enough, it's automatically put the dog in free. So this would simulate if the dog is on leash, you tell them to come. If they come within a certain distance, then the device automatically picks up that the dog has arrived and it does not issue a correction. This in the future will be done using ultra wideband sensors so that all the distance detection won't be subject to any false inputs from people pulling a leash or it getting caught on anything. It will be simply built into the belt clip. And this will also integrate the remote. Thank you. Goodbye.